What I'm looking at here is a conduction star. And what I have here is a metal rod connected to a brass hub here. And extending from this hub, I have 1, 2, 3, 4, 5 different arms, if you will, different pieces of metal that are protruding from that central hub. And they're all made of different materials here. This one here is listed as aluminum. This one is made of brass. This one is steel, nickel, and copper. And what we've learned so far is that different materials or substances have different specific heats, meaning they transfer heat either quicker or slower than other materials. So materials that have high specific heats tend to transfer energy very slowly and require a lot of energy just to change its temperature. But objects like metals that have low specific heats transfer energy very rapidly. Okay, they are able to increase in temperature or decrease in temperature very quickly compared to other objects that have high specific heats. Now, not all metals have the same specific heat, and aluminum, nickel, copper, steel, and brass all have different specific heats, meaning that all of them should heat up and slow down at different rates. So the idea here is that we are going to place this conduction star into an open flame, so a heat source. And we're going to place this central hub here that again is made of brass. We're going to place that into or directly over the center of that flame, and we're going to observe how conduction takes place. Again, these are made of different metals, therefore they should transfer heat at different rates. And the end of every single one of these little arms is a pit, and inside that pit is solid wax. Well, when wax is heated up, wax melts and turns from a solid to a liquid. So we should be able to easily identify the heat transfer through that metal by looking at the melted wax. Okay, so as we lift this star, we're going to place it over an open flame here. And as time goes by, here's a zoom in, a close-up of that wax. Okay, it's still in the solid state. As the time goes by and this central hub is placed over the center of the flame, heat is going to conduct or transfer through each one of those arms. Okay, so there's a series of collisions that's occurring. So as those molecules become excited and heated up, they're going to move quicker, they're going to move more rapidly, they're going to expand, they're going to move further away from each other. They're going to set off a series of chain reactions throughout the arm of each individual one. So I can already see copper starting to melt here. It's no longer white, but all these other ones, still white, still solid. I'm looking at copper. Copper's no longer white. It is completely melted. Copper has the lower specific heat of the 5 metals. Okay, so as time continues to pass by, I'm looking at as all these molecules are interacting with one another and creating that chain reaction, heat is being transferred down these arms here. So I'm looking at a couple. Looks like brass is pretty close to melting. It's already starting to turn a little clear. And sure enough, brass is completely 100% melted. So brass has the next highest specific heat, and therefore it melted the second fastest. Okay, so now as I look at steel and nickel, they're still going strong. I still see some solid wax over there. Okay, they have higher specific heats than the other metals, meaning that they're going to withstand that, or the heat's going to transfer a lot slower than it is in the other metals. Okay, now obviously as time goes by and I have this in the heat source, eventually that wax will start to melt. And you can see brass is gone, aluminum should be gone as well. I'm waiting on these two. Now, while we're waiting, you can see vapor leaving the brass and the copper pits here, because that wax went from solid state to a liquid state, and now it is still continuing to absorb that energy. and move from the liquid phase now onto the vapor phase.